Welcome back, everyone. I hope you guys had a really great break and you're ready to start your second semester. We're starting this semester in Unit 8, and this unit is all about exponents and working with exponents. We're going to be working with exponents for the rest of the semester, so this unit is pretty important for you to be successful in later units. Okay, so we're going to start off with the basics of exponents. So what are exponents and how do they work? So let's take a look at these two expressions that look really similar but behave very differently. So when I say 2 times 5, what does that mean? I know you all know that's 10, but why is it 10? Well, 2 times 5 is saying, well, I want to take the number 2 and add it 5 times. That's the math we're doing. That's why it equals 10, because 2 plus 2 plus 2 plus 2 is 10. So in a weird way, when you multiply two numbers, you're actually adding it that many times. So we're adding 2 5 times. That's actually why we call it times, like 2 times 5. We're saying 2 5 times. So that's why we use that word times to say multiply, which is kind of interesting. Okay, what is the difference between that and say 2 to the 5th power? Well, 2 to the 5th power is not saying 2 times 5. 2 to the 5th power is now saying that we want to multiply the number 2 5 times. So now instead of adding 2 5 different times, we're actually multiplying 2 5 times, which is definitely not 10, right? If I do 2 times 2, I get 4. The other 2 times 2, I get 4. 4 times 4 is 16. And then 16 times 2 is 32. So when we use exponents, exponents is a form of multiplying that number that many times. So 2 to the 5th power is actually a form of multiplying the number 2 5 times. Okay. So, now let's take a look at what the definition really is of an exponent. I know a lot of you know how an exponent works and what it means, but I want to make sure that as we're going into this semester, you have a really, really strong sense of when we have an exponent. There are lots of dictionary definitions, but I'm going to give you one that I think makes the most sense. So an exponent refers to the number of times that a number is multiplied by itself. So in this previous example right here, 2 to the 5th power, we're multiplying 2 by itself 5 times. Okay, so that exponent tells us how many times you're multiplying that number. Okay. There are a couple ways terminology we use to describe an exponential term. So this number right here, the number that's to the bottom of the exponent, we call that the base. So 2 here is the base and 5 is the exponent. We also use the word power, 2 raised to a power of 5, 2 raised to an exponent of 5. Those words mean the same thing. Okay, and then 32 is actually a representation of what we talked about before of 2 times 2 times 2. That's where we're getting the 32 from. Okay, so this is like the basics of how exponents work. Other things that we need to be able to do is think about coefficients. So in this example, we're going to identify the base, sometimes bases, exponents, and coefficients of the following exponential expression. So we know that a coefficient right now is if I have 4x, this is my coefficient, right? It's the number in front of the term. So when I look at example A, I don't see a number here, so I know that my coefficient, and I'm going to abbreviate to this, is actually that invisible 1 right there. So my coefficient is the number 1. My base, in fact, I want to abbreviate, but I won't for this first one. The base is x, right? This is my base right here is x, and my power is 6. Okay? All right, so I know the screen just changed a little bit. I went ahead and decided to use some highlighters to kind of make it a little bit easier to see. And then I also added in this labeling. So if you want to pause your video right now and kind of add this labeling in, so when we go through it, it kind of makes a little more sense, that's totally fine with me. So that's up to you if you want to pause or not. I'm going to keep going. So what I want to do here is I'm just going to go through all the coefficients of these first. Okay, so I'm going to use my highlighter, and I'm just going to talk about the coefficients of each one. So in letter B, this one's very strange, okay? The coefficient is not -3. The coefficient is just this negative right here. I know that's weird, okay, but the 4, the exponent, is only attached to the 3. It's not attached to the -3. Now versus this problem right here in letter C, 4 is attached to the -3, so our coefficient is an invisible 1 outside of that. So a really important part of working with exponents is recognizing a coefficient, okay? And sometimes that's really hard to see. So in this case, oh, I used the wrong color. I'm sorry, guys. Sorry, this should be, ooh, that changes to red. That's pretty awesome. All right, let's try this again here. We want to make sure, I want to make sure that you guys are figuring out these coefficients correctly. So in letter B, my coefficient is actually -1, and in letter C, it's actually just a +1. Okay, and we can see that here if I put the invisible 1 right here in front and then a -1 right here. So this is kind of like saying -1 times 3/4, which I know is very, very strange. Okay. In terms of the base for these two problems, I'm going to kind of erase that a little bit. The base for these two problems is going to be a little different. For the base here, that's going to be the 3. That's the base. It's what's attached to the 4. But for this problem, it's actually -3 is our base. So one base is 3, one base is -3. It is vital that you can recognize this. Okay, extremely important. It's going to be coming up a lot, and you're going to make sign errors if you're not careful. Okay, and then the exponent for both of them is pretty obvious. The exponent is going to be 4 for both of these, because there's the 4 right here. Okay. All right, letter D. I've got a coefficient of 2. So there's my coefficient of 2. My base is at x right there. So there's the base is x, and my exponent is just the number 3. So that one is a little bit easier to see because it's just the number 3. Okay. Letter E actually has 2 different bases. Okay. So we've got an A base and a B base. So that's okay. Sometimes terms can have multiple bases. I'm sorry, I'm not used to using the highlighter. Okay, so there's my one base and there's my other. So I have a base of A and a base of B. Okay, those are not just one base. It's not A, B. That is A, and then B is a separate base. And then I've also got 2 separate exponents. I've got the exponent of 3, and I have the exponent of 7. So 3 and 7 are my exponents. Now, I don't see a number in front, so that tells me that I've got an invisible coefficient, and whenever it's an invisible coefficient, that is a coefficient of 1. Okay, there's going to be a lot of invisible coefficients. Okay, letter F, the coefficient is pretty obvious. That's a -4. So my coefficient is -4. Sorry, I'm not used to using this highlighter, so be patient with me, guys. Sorry, it's doing really odd things. I'm just going to use the pen here. Okay, -4. My bases, I've actually got 3 of them. I have a base of A, a base of B, and a base of C. So we're going to write all those down. A, B, and C are my bases. And here's where something very strange happens. Okay, I know that I have a base of exponent of 4, but I don't see an exponent with B. And anytime you have a term but you don't have a number with it, that's an invisible 1. That B does have an exponent, it's just you can't see it. You're really multiplying B by itself 1 time. So it's just B. So there's an exponent of 1, and then my other exponent right here is 3. So every base has an exponent. You can't have a base without an exponent, it's just sometimes it's an invisible 1. Okay, so thanks for being patient with my highlighters. Trying to learn a new thing. The next thing that I want us to be able to do is I want us to be able to look at an expression we have and be able to rewrite it using exponents. Like, look how long all these are. We don't write this way in math because look how much space it takes. The whole point of exponents is to be able to make smaller expressions so we don't take up all this space. So in letter A, I count how many I have. I have 1, 2, 3, 4, 5 2's, so that's 2 to the 5th power. Letter B, I have 1, 2, 3, 4, 5 x's, so that's x to the 5th power. Letter C, I've got a's and b's. Well, I've got 4 a's, so that's a to the 4th, and I've got 2 b's, so that's b squared. Letter D, if you can simplify, do. Do I know what 2 times 3 is? Yes, it's 6, so I'm going to write 6 there instead of 2 and 3. And sometimes, again, I like to cross things out once I've used them so I don't make a mistake. I've got 2 x's, so that's x squared, and then I've got 2 y's, which is y squared. Now be careful with letter E. This is saying -4 times -4 times -4 times -4. That's going to be -4, and then you've got to put it in parentheses, and that's 4 times. If you don't put it in parentheses, and I'm going to put right here the wrong answer, if you do this, then you're saying this. And those are very different answers, okay? Because this one's going to be negative, but this one's going to be positive, okay? So I need you to be extremely aware of parentheses in this semester. It's extremely important. You'll get the wrong answer, and we want to get the right answer here, okay? Finally, D, I'm going to count my A's. I have 1, 2 A's, so that's A squared. I have 1, 2, 3 B's, so that's B to the 3rd. And I have 2 C's for C squared. So A, B, C. And you also want to keep it in alphabetical order, all right? That's important as well, okay? Another thing that I want you to be able to do, and I'm happy to use a calculator. We need to learn to put these in the calculator correctly. A lot of these are really big numbers. I don't expect you to be able to do 5 to the 5th power. I want you to be able to recognize that it's this, but at some point these numbers get very large very quickly. Okay, that's kind of the thing with exponents. It doesn't just grow by an equal amount. It gets very, very large very quickly. So I know that 5 to the 5th is 5 times 5 times 5 times 5. But I can do 5 times 5 in my head. That's cool, 25. Right? And then I know that this is also 25, and then times 5. I might not know 25 times 25 at the top of my head, and even if I did, I'd have to multiply that by 5. So I don't want you to do this work, right? We have calculators for a reason. So what I want us to do is be able to use our calculator. So I'm going to turn on my calculator, and I hope you guys have them by now. If you don't have a calculator by now, this semester is going to be a struggle. Because if you don't have a calculator for this, how do you do it? Like, that's a big thing standing in your way, and I don't have enough to loan out. So this needs to be something that you put a priority on, okay? So how do we put this in our calculator? Well, I'm going to hit the number 5, and then there's a little button right here. Do you see my mouse cursor hovering over this right here? That's called a tilde. And when you put that in your calculator, oops, I accidentally put in 2. I'll delete that. That's an exponent symbol. So 5 tilde to the 5th, and then you hit enter, and you get this big number of 3,125. Okay. Okay, the second one, 2 to the 11th power. So I'm going to pick the number 2, tilde, and to the 11th. Not so bad, right? Pretty easy. Look how big that number is. You wouldn't think it's that big of a number, but it gets very, very big. So 2,048. Now, be very careful here. This says -6 squared. When you put this in the calculator, it needs to be exactly like you see it. So I see a negative, I see a 6, tilde to the 2nd power. When I hit enter, -36, which is very different than the next problem. The next problem has parentheses, so in my calculator, I'm going to put a parentheses and do -6 parentheses. Then I hit the tilde, then I hit the square. Notice I get a positive 36 when I do this. Okay, these are very different answers, and I will mark that wrong. A sign is a sign, and it needs to be the correct sign. Okay. So why don't you go ahead and in your calculators, you can also use your like a calculator on your computer. You can also Google a calculator if you want to. There are lots of options for you on the computer to do this. So go ahead and pause and see if you can get the correct solutions for these next 4 using your calculator. All right, these are the values you should have gotten for the bottom 3. And if you didn't, I think I might know why. So for this one, I'm going to put a little asterisk next to it. I bet if you got this wrong, it's because you didn't put in your calculator the exact way it's written. I bet some of you did -3 times 6 first. I guarantee it. I see it 100 times a semester that you don't do the exponent first. If you do -3 times 6, hit enter, and then hit tilde5, you're going to get a really, really big number. Because you're saying that you're taking this -3 times 6 to the 5th power. But in reality, what's the thing going to the 5th power? It's just the 6th. So you need to do 6 to the 5th power, then you multiply that by -3. Okay? And you get that -23328. If you also just put it in your calculator exactly how you see it, look how my calculator perfectly matches what's on my paper, and then you hit enter. Your calculator can also do order of operations perfectly fine that way. So you do not do this part first. That is a big no, no, no. You always do the exponent part first, and I guarantee I'll see it. I can tell you guys a million times, but it's going to happen, and that's okay. We just have to learn from our mistakes, okay? It's an accident, but it's a really important thing that we fix going forward, okay? The last thing that I want us to be able to do is being able to have, when we have variables raised to an exponent, I want us to be able to evaluate these expressions. Now, evaluate's a word we haven't seen in a while, but evaluate basically means that you plug in and get a value. Okay? So for y to the 4th power, I'm going to go look at what y is equal to. So y is equal to -1. I can see that right here. There's y, -1. So when I rewrite this expression, and remember, when you plug something in, you should always use parentheses, especially if it's a negative number. So I've got -1 to the 4th power. Okay? And then I'm going to use my calculator just to be safe. I've got -1 to the 4th power, and when I plug that in, I get +1. Which kind of makes sense because -1 times -1 times -1 times -1 just gives me 1. Okay, I've got 4 positives give me a positive number. All right, 3x to the 3rd power. That's going to be 3. Then parentheses, what is x? X is 5 raised to the 3rd power. Okay, now I know that 3 to the 5th power is 125, and I also know that 3 times 125 is 375. Okay, that's math that I know, so I'm not going to put it in my calculator when I do it, but when you do it, if you want to, you can, and you'll see that my number does match the calculator number. So if you do know something in your head, fine, go ahead and use your head, but if you're just not sure, want to double check, you know me. I encourage you guys to use the tools that you have. Okay? 2 times y to the 2nd. I've got 2, then -1 to the 2nd. Notice how I used parentheses. Okay? 2, I'm going to leave it in front here. -1 squared is +1, so I get +2 as my answer. Okay? Z squared. I'm going to plug in 4 for z. Square it. 4 squared is 16. All right? Y times z squared. So I'm going to make some big parentheses here. Y is -1, so there's -1. Z is 4. So I'm going to put -1 times 4 inside that parentheses, and then that is what gets squared. Okay? Simplify what's inside first. -4, and then squared. And then -4 squared is +16. All right, plugging it in correctly matters, because if you plug it in incorrectly and still use your calculator, the calculator is going to get it wrong because you plugged it in wrong. So be really cautious here, okay? This is similar. Now I've got y times x. Y is still -1. X is 5. Okay, so I'm going to end up with -5 to the 3rd power. In that, I want to make sure I get my sign correctly. Now, I know that's going to be negative, but if you don't know, go ahead and plug it in. -5, parentheses, tilde3, and I get -125. Signs are important. Sorry, I keep pushing that button. Okay, and then the last two, and then we're almost done here, guys. The last two, I've got x squared, z squared. So x is 5, z is 4. So 5 squared is 25. Always do your exponents first. 4 squared is 16. Now, I can't do that in my head. I don't really want to, so 25 times 16 is 400. So I end up with 400. And then take a look at this last one, y to the x. That doesn't mean y times x. That means you plug in something for y, which is -1, and then raise that to the 5th power because x is 5. Okay, now that's very strange, but we can plug in numbers for exponents that we don't know. And that's going to come into play a lot next unit. Okay, so I'm showing it to you now so you're prepared. Go ahead and plug that into your calculator, -1 in parentheses, ~5, and you end up with -1. Okay, so these are some basic skills in exponents. We're starting off pretty basic. A lot of you probably already are familiar with this and know what to do, but we're gonna start it off slow this semester. All right, so go ahead and start your practice. I'm here to help you, and I'm looking forward to seeing you guys again. Good luck.